Hello friends, welcome back to our channel, The Quantum Quest.
In the previous video, we have learned the scalar product of three vectors. In this video, we are going to discuss vector product of three vectors. If we have three vectors, vector A such that a1i plus a2j plus a3k, b equals b1i plus b2j plus b3k, c equals c1i plus c2j plus c3k. Then the vector product of three vectors a cross b cross c equal to a dot c into b minus a dot b into c. This is very important formula.
Let's move on to the proof of the formula. The LHS is A cross B cross C. So first we have to find B cross C. B cross C is the cross product of B and C. We already know the formula to find cross product. That is determinant I, J, K, B1, B2, B3, C1, C2, C3. By determinant operation, we get I into B2, C3 minus B3, C2 minus J into B1, C3 minus C1, B3. For simplification, we interchanged the order. So, plus J into C1 minus B1, C3. The correct formula is minus J into B1 C3 minus B3 C1. We interchanged the symbol, so we get plus J into B3 C1 minus B1 C3 plus K into B1 C2. K into B1 C2 minus B2 C1. So this is B cross C. Then cross this B cross C cross with A. That is A cross B cross C equals I, J, K, A1, A2, A3. This is the answer we get B cross C. That is B2 C3 minus B3 C2, B3 C1 minus B1 C3, B1 C2 minus B2 C1. By doing the determinant operation in the same way, we get I into A2 B1 C2 minus B2 C1 minus A3 into B3 C1 minus B1 C3 plus J into A3 B2 C3 minus B3 C2 minus A1 into B1 C2 minus B2 C1 plus K into A1 B3 C1 minus B1 C3 minus A2 into B2 C3 minus B3 C2. When we open the bracket, we get this term as negative and this term as positive. Okay, we can take B1 as common from this and this. This is positive when open the bracket. So, we can take B1 as common. So, I into B1 into A2C2. A2C2 from here and A3C3. From here is A3C3. So, B1 A2C2 plus A3C3. Similarly, we can take C1 common from the negative terms. Here and here. We can take C1 as common. So, C1 into A2 B2 plus A3 B3. Similarly, we can take B2 as common from these two terms and C2 as common from these two terms. So, we get B2 into A3 C3 plus A1 C1 minus C2 into A3 B3 plus A1 B1. Similarly, in the kth term also, we can take common as B3 from here and C3 from here and here. So, the formula is B3 into A1 C1 plus A2 C2 minus C3 into A1 B1 plus A2 B2. So, this is LHS. Now, we have to find RHS. We know RHS is A dot C into B minus A dot B into C. So, we know A, B and C. So, A dot C equal to A1 C1 plus A2 C2 plus A3 C3. This is the dot product of two vectors. We already learned how to find dot product. Then this quantity is a scalar quantity. then this scalar quantity is multiplied with vector b. We know vector b is b1i plus b2j plus b3k. This vector b is multiplied with this a dot c. Then each component of the vector b is multiplied with the components of a dot c. Then we get I into a1 c1 b1 plus a2 c2 b1 plus a3 c3 b1. This is the component of the b vector, that is bi into a1 c1 plus a2 c2 plus a3 c3. Similarly, jth component plus j into a1 c1 b2 plus a2 c2 b2 plus a3 c3 b2. Similarly, the kth component k into a1 c1 b3 plus a2 c2 b3 plus a3 c3 b3. In the same way, we can find a dot b into c, that is I into a1 b1 c1 plus a2 b2 c1 plus a3 b3 c1 plus j into a1 b1 c2 plus a2 b2 c2 plus a3 b3 c2 plus k into a1 b1 c3 plus a2 b2 c3 plus a3 b3 c3. Now we want to find a dot c into b minus a dot b into c. So this is the formula for a dot c into b, and this is a dot b into c. Look at these formulas. We have common terms. So this is negative minus a dot b into c. So we can cancel the common terms. a1 c1 b1, and here these two terms get cancelled, and similarly these two terms get cancelled. Then k into these two terms get cancelled. So the remaining terms are I into b1 a2 c2 plus a3 c3 minus c1 a2 b2 minus a3 b3 plus j into b3 into a3 c3 plus a1 c1 minus c2 into a3 b3 plus a1 b1 plus k into b3 into a1 c1 plus a2 c2 minus c3 into a1 b1 plus a2 b2. Now we got the formula for RHS. This is equal to LHS. Look at these two formulas. This is the formula we get on LHS. This is exactly same as this RHS. So LHS and RHS are equal. Then it's proved. Let's do a simple example. Let A equals I plus j minus k, B equals I minus j plus k, and C equal I minus j minus k. Find A cross B cross C. So we have already know the formula. A cross B cross C equal to A dot C into B minus A dot B into C. So first we have to find A dot C. So A dot C equal to A is here and C is here. So A dot C equal to I plus j minus k into I minus j minus k. That's equal to I into I equal to 1, j into minus j equal to minus 1, minus k into minus k equal to plus 1. That's equal to 1. Then it multiplied with the vector b. Vector b is I minus j minus k. So we get the vector j, I minus j plus k. Then we have to find A dot b. A dot b is here the vector A. Vector A is here and vector b is here. So A dot b equal to I plus j minus k into I minus j plus k. That's equal to I into I equal to 1, j minus j equal to minus 1, minus k into k equal to minus 1. That's equal to minus 1. So A dot b into c equal to minus of I minus j minus k. So we get A dot b into c and A dot c into b. So A dot c into b minus A dot b into c equal to I minus j plus k plus this minus and the minus in the formula become plus. So I minus j plus k plus I minus j minus k equal to 2i minus 2j. This is a very simple example. Try to do it yourself. The product of three vectors is an important tool in mathematical physics. I hope this video will be helpful for you. Thanks for watching.